back to Mathematics Lifeline. In today's video, we're going to be doing a math problem from every grade level in our American school system. So I'd like for you to try some of these out and let's see how many you can get and how far you can go. We'll start at kindergarten and we'll end at undergraduate level college math. All right, so we're going to do a question from every one of those grades. So without further ado, let's go ahead and get started. So we're starting here with kindergarten. So the question says you have 5 apples and your friend gives you 2 bananas and your teacher gives you 3 more apples. How many pieces of fruit do we have? So the first thing we want to make sure of is that everything that we're getting or that we have is already a fruit. So an apple is a fruit, a banana is a fruit, and the apple again, right, is obviously going to be a fruit. So all we need to do to figure out the total number of fruits is just add up what we have. So we already had 5. But we need to add the 2 bananas that our friend gave us, right? And then we need to add the 3 more apples that the teacher gave us. So when we add all these together, we'll get the total number of fruit. So when we do that, we get 5 plus 2. That ends up giving us 7. We still have this plus 3. And 7 plus 3 is equal to 10, right? So we know that there are 10 total pieces of fruit. So hopefully you're able to get that one. We're going to go ahead and move on to the first grade level. All right, so we made it past kindergarten. So let's go ahead and go to the first grade level. So this question says, if you count by threes starting from 0, what is the 7th number you say? So when we say we start from 0, that means we're not including 0. We're just going to count from threes past that. So let's go ahead and write down all those numbers, right? If we're counting by threes, the first one is going to be 3. Then the next one, we're going to add 3 to it. So that's going to give us 6. And then 9, and then 12, 15, 18, and 21. Now, if you notice, this is 1, 2, 3, 4, 5, 6, 7 numbers. So we have our 7th number right here. That's the last one. That is 21. So our answer for that one is going to be 21. So again, still not too bad. Hopefully you're able to get that one. And we will move on to the second grade. All right, so here we are in the second grade. So this question is, if a train has 6 cars and each car has 9 passengers, how many passengers are on the train? Now there's options with how we can solve this one, right? We can kind of draw a little picture out and then we could count out all the passengers that we draw, but that's going to take us a while. The easiest way is to kind of recognize what type of question this is. So we need to use multiplication for this question because we have 6 groups and there's 9 things in every group. Right, so 6 cars and there's 9 passengers in every car. So that tells us that if we want the total number of passengers, we need to take the number of cars and we need to multiply by the number of passengers. So 6 times 9, and that will give you 54 total passengers. So that's going to be our answer right there. So the easiest way to do that one is to see that it's multiplication instead of drawing out a picture because it would just take a while. But yeah, that's it for the second grade. We're going to go ahead and move on to third grade. All right, so we made it to third grade. This question says a farmer has 24 cows and needs to split them into equal groups. What are all the possible group sizes? So what this question is asking us for is how can we evenly divide 24, right? So we need to think about the numbers that we can divide 24 by. So the easy group size would be 1, right? We could have 1 cow in every group, right? And that would be an even number of groups. We could also have one big group of 24, right? That's an option as well, because if we just have one group, we just put all the cows in the one group. So now we want to think about the numbers in between and what can we divide those by? So 24 is an even number, so we can divide it by 2. So we could split those into groups of 2. That would be fine. We can also divide it by 3 because 24 divided by 3 is equal to 8, right? So that means there would be 8 groups of 3 cows. We could also divide by 4, right? 4 is an option too because 24 divided by 4 is equal to 6, right? And so that would mean that we'd have 4 groups of 6 cows. And then, of course, we can also divide by, we can't do 5, but we can do 6, right? Because we knew from 4 that we could divide it by 6. So we can also do 6, because 24 divided by 6 is 4. And we can't do 7, but we can also do 8, right? Because 24 divided by 8 is 3. So 8 works as well. And then the last one, you can try every number, but the last one that will work is actually going to be 12, right? Because if I divide 24 by 12, I get 2, right? So you can kind of see how they pair up here. The 1 pairs with the 24, the 2 with the 12, 3 and 8, and 4 and 6, right? They pair together. And so these are just finding all the factors of 24. So our possible group sizes are 1, 2, 3, 4, 6, 8, 12, and 24. So yeah, that was it for the 3rd grade. Let's go ahead and move on to 4th. All right, so here we are in the 4th grade. This question says, find the least common multiple, or the LCM, of 12 and 15. So there's a lot of ways we can go about this. Some people like to kind of break them down into their common factors, but I think for this question in particular, it's going to be easier if we just write out the multiples of 12 and 15. Right, so let's look at the multiples of 12 first. So multiples of 12. So, of course, we can multiply 12 by 1, and we would get 12. If we multiply by 2, we get 24. By 3, we get 36. By 4, we get 48. And by 5, we get 60. By 6, we get 72. And we could keep going, right? We could go on. Those are all the multiples of 12. Now, let's look for the multiples of 15. Now, the benefit of doing this is that when we do it this way, whenever we see two numbers that match, as long as it's the first number that matches in both of them, we know we're actually done. So we can multiply 15 by 1 and get 15. Now, that doesn't match anything. We don't have a 15 in there. 15 times 2 would be 30, so that would go next. That doesn't match either, right? We have 36, but that's not 30. 15 times 3 would give us 45. Again, that doesn't match. We only have 48. But 15 times 4 will give us 60. So we actually have a match right here. And of course, that was the first one because we tried every option, right? We tried 1, 2, 3, 4, 5, 1, 2, 3, 4, right? There was nothing that came before that. So 60 is our least common multiple. So the LCM is equal to 60. And that will be our answer. So again, there's multiple ways we can do that, but for this one, it happens pretty early when they actually end up being the same thing. So I think this is the easiest way to do this one. So yeah, that was the end of 4th grade. We'll move on to 5th. All right, so here we are in our last year of elementary school in 5th grade. So this one says, a rectangular swimming pool is 25 meters long and 10 meters wide. If you swim along the edge twice, how far do you swim? So what we're looking for here is the perimeter, right, of our pool, and we need to multiply that by 2 because if we swim along the edge, we're actually finding the perimeter. So let's kind of draw a picture of what this looks like. So I'm going to use this side is going to be my 10 meters wide, right, because this will be the width, and this will be the length of the pool, right? So we know that it's 25 meters long, and we know it's 10 meters wide. And since it's a rectangle, these are the exact same. So this is also 10 meters, and this is also 25 meters. So when we're looking for the perimeter, all we have to do is add the sides up. So the perimeter, right like this, is equal to 25 plus 25, because we have 2 of those side lengths, plus 10 plus 10. So the total perimeter is equal to, this is 50 and this is 20. So 50 plus 20 is 70. So 70 meters is the perimeter. But remember, we swam along the edge twice. So our actual answer is 2 times 70, which is equal to 140 meters. And that will be what we box in as our final answer. So yeah, this one was just asking for the perimeter of a rectangle, and that's something you would see in your 5th grade classes. So yeah, that's it for elementary school. So now we're going to go ahead and move on to 6th grade and go into middle school. All right, so welcome to middle school. So our first problem of the middle school career is going to be solve for x in this equation. So we have 2x plus 3 divided by 5 is equal to 7. So we want to figure out how we can solve for x here. Now, the way that I would like to solve for this one is going to be, we want to eventually clear out this fraction, right? We have this big ugly fraction here and it's making it harder. So we want to try to clear that out in some way. So the way we can do that is if we multiply both sides of the equation by 5, right? Because what happens now is this 5 that I have multiplied by can cancel with the one in the denominator. So I can cancel them on this side. And over here, it's just multiplication. So this side right here has turned into just 2x plus 3, because we were able to cancel those 5s. And then the right side, 7 times 5, we can solve that, and that's equal to 35. So just by getting rid of that fraction, we've made this a little bit easier to solve. So now what we want to do is to get the solution for x, we have to get x by itself. So we want to try to just isolate this x part. So we need to get rid of this 3. So let's subtract 3 from both sides. So that will give me 2x. Now this goes away, right? Because 3 minus 3 would be 0, and so we don't need to put 0 in there. And that equals 35 minus 3. Well, 35 minus 3 is just 32. And then finally, to solve for x, well, we need to divide by 2. Because if we're multiplying by 2, to get rid of that multiplication, we have to divide. So if we divide both sides of the equation by 2, then that's going to give me, right here, these 2's will cancel. So I just have x left on the left, and the right side is 32 divided by 2. That's equal to 16. So the x value here is equal to 16. And again, we can check that because remember our original was 2x plus 3. I'll write it here. 2x plus 3 over 5 equals 7. Now let's see what happens if we plug in 16 to check our answer. That'll be 2 times 16 plus 3 over 5, which will turn into, this is 32. So 32 plus 3 over 5, which is the same thing as 35 divided by 5, and that is equal to 7, right? So we know that our solution for x worked out. So yeah, this was our first actual algebra problem of this video. So that's it for 6th grade. Let's go ahead and move on to 7th. All right, so here we are in the 7th grade. So we are actually going to be adding fractions for this question. We're going to need to simplify 4 over 9 plus 5 over 6. So for us to add fractions, remember that when we add or subtract fractions, we have to have the same denominator. And we actually don't right now because the one on the left is 9 and the one on the right is 6. So we need to try to find a common denominator. Now the best way to do that is going to be to look for the least common multiple. So like what we did earlier, we're going to do the least common multiple of the 9 and the 6. And when we find that, we're going to make that our new denominator. So let's look at the multiples of 9, right? We have 9, we have 18, we have 27, 36. We won't even need all of those. And then when we look at the multiples of 6, what do we have? We have 6, 12, 18. So we have our first match at 18. So that means that when we're going to do this, we're going to change these into 18s on the bottom, right? Because then they will have a common denominator and we'll be able to add them. Now, we can't leave these as 4 and 5 though, because remember, if we multiply down here by something, we have to also multiply it in the top. So to get from 9 to 18, we had to multiply by 2, right? Because 9 times 2 is equal to 18. So we really need to multiply this 4 by 2 as well. So 4 times 2 is equal to 8. So we have 8 over 18. And then we're going to add, well, what do we need to multiply the top by here? Well, we went from 6 to 18. So we had to multiply 6 by 3. So that means we need to multiply the top by 3 as well. So 5 times 3 is 15. So these are the exact same fractions, right? Nothing has changed because we multiplied in the top and the bottom, right? So it doesn't change anything. And now they have the same denominator. So we can just go ahead and add them directly. So when we do that, the 18 is going to stay down here, but the top is just 8 plus 15. And 8 plus 15 is 23. So this will actually be our final answer because that can't simplify anymore. There's nothing you could divide both of those numbers by. So 23 over 18 is going to be our simplified answer. So yeah, that's it for 7th grade. Let's go ahead and move on to the 8th grade. All right, so welcome to the 8th grade. So this question, again, we're going to be solving for x, so another algebra type question. Now, there are actually a lot of ways we could go about solving this, so the way I do it might be a little different from how you did it. But the way that I'm going to do this is I'm going to go ahead and distribute this 3 into this or into that term right there. So remember, when I distribute, I have to multiply this term by this term and by that one. So this is going to be 3 times x, which gives me 3x. Then I have 3 times negative 2, and that's going to be negative 6. And then now I still have the plus 4, and I still have it equals 19. I didn't change anything over there. So all I did for the first step was just distribute that 3. Now I have some like terms that I can combine, right? I have two numbers here, and I know I can add negative 6 plus 4. So the 3x is going to stay the same, but negative 6 plus 4 is going to be negative 2. So 3x minus 2 equals 19. And then now this is like solving a normal algebra equation. We want to try to solve for x. So what we need to do is isolate it. So we need to get rid of this 2 right here. So since we're subtracting it here, we want to add it to both sides. So plus 2 plus 2. So this will cancel out. I just have 3x on the left now. And on the right, 19 plus 2 gives me 21. And then now my final step to solve for x, I just need to divide by the 3. Right? It's being multiplied here, so I want to get rid of that. So I have to divide. So I divide both sides by 3. This 3 cancels with this 3. So I get x is equal to 21 divided by 3 is just equal to 7. So x equals 7 is my answer. And again, we can always check this answer. That's what's nice about it. So if I plug 7 in for this x, I get 3 times 7 minus 2 plus 4 equals 19. So remember, I always will do the parentheses first. So 7 minus 2 is 5. So I get 3 times 5 plus 4 equals 19. And this 3 times 5 is 15. So 15 plus 4 equals 19, right? Because 15 plus 4 is 19. So we have that 19 equals 19, and we know that our x value worked. So that's our answer for the 8th grade. Now we're going to be going to high school. So we'll start with the 9th grade right now. All right, welcome to high school. We're finally in 9th grade. So this is where we're really going to start picking up the difficulty on some of these. So let's go ahead and get started with this one. So it says solve for x, and we have x squared minus 7x plus 10 equals 0. Now the important thing to remember about this is that we actually have what's called a quadratic equation, right? Because we have this x raised to the second power. So what that means is that we're going to have two solutions for x instead of just one. Now, there are a lot of ways we can solve for that. One that always works would be the quadratic formula, but this one actually factors pretty nicely. So we can actually work with the factored form. So the way that I like to do that is I like to set up what's called an X puzzle. So we make a big X right here. Now this one right here we're going to have as a multiplication, and this one's going to be addition. Now what we do is we're going to put the last term in this bottom section. So that's going to be the 10 we're going to put there. And then we're going to put the middle term, so this negative 7 that we have here, that's going to go right here. So what I'm looking for here, and this is kind of like a puzzle, we're looking for two numbers that will add to give me negative 7 and will multiply to give me 10, right? So I want to find two numbers that will add to get negative 7, multiply to get 10. Now, the easiest way to do this is usually to look for the factors of 10, right? So 10 can either be 1 and 10, or it can be 2 and 5. So I think the one that makes the most sense would be 2 and 5, because we know that 2 plus 5 is 7, right? But we're looking for negative 7. So we actually are going to need negative 2 and negative 5, right? Because if we take negative 2 and we add negative 5, that gives me negative 7. And if I multiply these two, well, the negative will cancel and it'll give me 10. So that's what we're looking for. So that means that this factors to, it's always x and then whatever this number is. So negative 2 in that case. And then we have x, and then we have a negative 5 equals 0. So this is the factored form, right? If we were to FOIL this out, we would actually get this again. So that's the factored form now. And then now what we need to do is we need to set both of these equal to 0 to find our two solutions for x. Now the reason we have to set them both is because if either one of these is 0, right? So like if this one was a 0, then we're multiplying something by 0, and that gives me a 0. But the same thing for this one. If this was actually a 0, then I would multiply 0 by a number, and 0 times any number is still 0. So we have two solutions here. We have the one where x minus 2 equals 0, and we have the one where x minus 5 equals 0. So to solve for these, we just need to add 2 to both sides for this one, and I get that x is equal to 2. That's one solution. And then this one, I need to add 5 to both sides. So again, this cancels. I didn't say that, but this also cancels, and I get that x is equal to positive 5. So I have x equals 2 and x equals 5, they both work. And again, you can always check these by plugging them back in for your x in the original equation. So yeah, that's it for our first year of high school. That was 9th grade. We're going to go ahead and move on to our sophomore year, or 10th grade. All right, so here we are in our 10th grade. Now this one is actually going to be the first proof that we've had the entire time. Usually when you get into geometry, you actually are introduced to proofs, which is what you do in college level math. So this is kind of our first introduction. This question says, a triangle has side length 7 centimeters, 24 centimeters, and 25 centimeters. Prove that it is a right triangle. Now, you may not know exactly what I mean by prove that it's a right triangle, but what we have to do is we have to show, using some knowledge that we have before, that this does in fact give us a right triangle no matter what. So what we're going to use here is actually the Pythagorean theorem. So remember, if you might remember that one, it's actually a squared plus b squared equals c squared. So if we have a right triangle, right, with side length a and b, and then c is our hypotenuse, then for it to be a right triangle, this must be true, right? It has to be true that a squared plus b squared equals c squared. That's only true in right triangles. So we know that c is our hypotenuse. So 25 is going to be c, right? Because that's going to be the longest side, right? The hypotenuse just means the longest side of your triangle. So 25 is the longest side. That means that a and b can be either one. So I'll say that a is equal to 7, and we'll say b is equal to 24, right? It doesn't matter which one. It just matters that c is the hypotenuse, right? Now, to show that this is a right triangle, we know that we have to show that 7 squared plus 24 squared is equal to 25 squared. So we have to make sure that this is true. So we want to show that 7 squared plus 24 squared equals 25 squared. Okay? So what do we know? We know 7 squared is 49, right? So 7 times 7 is 49. Plus, now 24 squared you can do in your calculator. I'm going to do it by hand right here. So 24 times 24. Well, 4 times 4 is 16, so we carry the 1 and put a 6 down here. 4 times 2 is 8, plus 1 is 9. Then we go to the next row, we put a 0. Now 2 times 4 is 8. 2 times 2 is 4. So when we add this together, we get 6, right? We add now. 9 plus 8 is 17, so 7, and then 1 plus 4 is 5. So 24 squared is equal to 576. And now that has to equal 25 squared. Now 25 squared, again, we could do the exact same way. I happen to remember this one. This one is actually 625. So now the only thing we have to do is to show that this is equal to 625, but that's just as simple as adding. Right, if you added these, you would end up getting that it's equal to 625. So we get 625 equals 625. So we know that the a squared plus b squared was actually equal to the c squared. And so we've proven that it's a right triangle using the Pythagorean theorem. So yeah, this was our first kind of logical one that we had to do, right? We had to do an actual proof using a theorem. So pretty interesting there. So that was the end of our 10th grade. We're going to go ahead and move on to 11th grade. All right, so here we are in 11th grade. This is our junior year. So we're really getting close to graduating at this point in time. So we've gone through all these different levels. This is going to be the first one that we actually are going to use trigonometry in some way. So we have, the question says, express tangent squared of x plus 1 in terms of secant of x. So the trick here, and this is actually really hard if we don't know this trick, but one of the first things you'll learn when you're doing trigonometry is this identity. So you'll learn that sine squared of x plus cosine squared of x is equal to 1, right? So that's the main one that we learn, but there's actually two other ones that come along with it. So one of the other ones that we use involves tangent squared in 1 and secant. So the way that we actually can get that, and you may not need to know how you derive it, but I'll show you how you do, is if we divide every term in here by cosine squared of x. Divide everything here. Cosine squared of x, and then again, cosine squared of x. And let's see what we end up getting. So remember that sine over cosine is tangent, right? So this is like one of the things we learn in trig, is that sine over cosine is tangent. So this, if we have sine squared over cosine squared, that actually gives us tangent squared of x. Then we're going to add, well, cosine squared over cosine squared is just going to be 1, right? Because that's the same thing divided by itself. So it's just going to be 1. And this equals, well, what's 1 over cosine? Well, remember, 1 over cosine is always equal to secant. And if we have 1 over cosine squared, that's going to be equal to secant squared of x. So this is another one of the Pythagorean identities that we learned about. But if you notice, what do we have here? Tangent squared x plus 1. Well, that's exactly what we had here. And it's expressed in terms of secant x because it's actually equal to secant squared x. So if you remember that identity, this one would probably be the easiest question of all of these for you. You didn't even have to do anything. But we had to actually derive it here, but we get that tangent squared x plus 1 is equal to secant squared x. So that's how we can express it. Now, it doesn't help us for this question, but if you needed to get, there's one more Pythagorean identity. The way you get it is just by dividing everything by sine squared instead of cosine squared. So that'll help you for, your trigonometry math if you're still taking it. But yeah, so that's it for the 11th grade. We're going to go ahead and move on to our senior year of high school. All right, so here we are in our senior year. This is our last question of high school. Remember, we have one more, so be sure to stick around for the college level question. But for right now, we're going to evaluate the definite integral. So this is the integral from 0 to 2 of 3x squared minus 2x dx. Now, some of you, this may not even be familiar, but 12th grade is when a lot of students will start taking AP math classes. So the big one is going to be AP calculus. And this would be one of those types of questions that you would see. So this is a definite integral. So the way we have to do this is we have to use the power rule for integration. So when we take the integral of 3x squared, the rule is we add 1 to the exponent and then we divide the entire term by what that exponent is now. So we're going to have 3x, but instead of squared, it's going to be cubed because we add 1. And then we divide by this exponent right here. So we divide by 3. So that's the power rule for this one. We're going to do the same thing here. So we have minus, then we'll have 2x squared, right? Because this is originally x to the first, but we have to add 1 to it, and it gives us 2. And then we divide that by 2. So we evaluate this from 0 to 2. So it means we plug in 2, and we subtract off plugging in 0. Now, before we do that, we can make it a little bit nicer because we have 3's that can cancel here. So this 3 can cancel with this 3, and this 2 can cancel with that 2, actually. So we end up with evaluating x cubed minus x squared from 0 to 2. And so the way we do that is we plug in 2 first. So we have 2 cubed minus 2 squared. And then we subtract off plugging in 0. So we have 0 cubed minus 0 squared. Right, this one is just going to give us 0 because it's just 0 minus 0. So this term is just completely gone. Now this one, 2 cubed is equal to 8. And then we're subtracting off 2 squared, which is 4. So 8 minus 4 is equal to 4. And that's actually our answer right here. So evaluating that definite integral, what we really did, for those of you that are curious, that didn't take AP calculus, or calculus at all for that matter, we found the area under the curve. So when we think about area in a normal sense, right, we have our formulas that we use. But when we have a weird curve like this one, if you graph this, it would be a funky curve. We actually don't have a good way to find the area unless we use an integral. So that means that the area between 0 and 2 and under this curve is 4 units. So that's just a little more explanation behind it. Because this may be new for some folks. Not everyone takes calculus or AP Calc in high school. So yeah, that is it for our K through 12 schooling. I did want to throw in one college level question. So we're going to go ahead and get to that right now. All right, so congratulations. You've graduated and now you've moved on to college level math. So college level math, and just a little bit of backstory behind it, we actually move into proofs. So we want to prove the things that we know. Right, so we're going to prove things that are from calculus, and we're going to, develop these structures, and it's what's called abstract algebra. That's actually the type of question this is an abstract algebra type of question, But we build these structures and foundations and we prove certain things about them. So, for example, with this question, we want to prove that the set of even integers is closed under addition. Now, the terminology may be a little confusing, but let's remember what the integers are. So usually we denote that with a z like this. It's called I don't actually know what it's called, but it's a z with kind of two lines down the middle of it. If you all know what it's called, please let me know. But this is the set of integers. Now the integers are written like this. So we have, let's say, -2, -1, 0, 1, 2, 3, and so on, right? So we have just no decimals, right, and no fractions, really. So we have just basically our whole numbers and their negative versions. So that's the set of integers. Now, when we're looking at the set of even integers, we're looking at, of course, like our 0, 2, -2, 4, 6, those types of numbers. So when we do this, we want to remember what the definition of an even integer is. So when we look at an even number is always 2 times n, right? If we can write a number as 2 times some number, then it's going to be even. But remember that n, and what I'm writing here, this may be new notation for you, n has to be in the integers. That's what that means. We know this is our symbol for integers. This means is an element of. So n is in this set, essentially. If we can write 2 times some number in the set of integers, we know that that number is even. So that's all we really need to know to prove this. So let's go ahead and write our proof. So this has to be arbitrary, right? We can't just choose 0 plus 2 and add that and show that it's even, because we have to show it for every possible number. So let's just say we're going to let a equal 2 times m and b equal 2 times n for some m and n in the integers. Remember, that's what this notation means. So for some m and n value that has to be in this set right here, we're letting a equal 2 times that and b equal 2 times n. Now, again, the logic behind this is these are both even numbers, because by definition, right, it's 2 times some number that's in the integers. So we want to show that whenever we add those together, we also get an even number. So we're going to consider a plus b. So consider a plus b, right? Because we do need to add these because we're talking about addition here. Now, we know what that is because we've said that a is equal to 2m and b is equal to 2n. So this is 2m plus 2n. Now, the trick to show that this also has to be even is we can actually factor a 2 out of this. So this is the same thing as 2 multiplied by m plus n, right? Because if I distribute that 2 in there, I get 2m plus 2n, so nothing changes. But now we know that this has to be an even number. Because if I add 2 integers, I'm going to stay in the integers, right? I'm never going to become, a rational number that isn't an integer, of course, by adding 2 integers, right? So no matter what I add in this set, as long as they're both in the set, it's going to stay in the set. And then also notice that we have 2 times an integer, and 2 times an integer means it has to be even, right? So we can call m plus n equal to k as an example. So it's this 2k for k equals m plus n, and that is in the integers, right? So just to kind of follow that definition a little closer. But we know that a plus b ends up giving us, by definition, an even number. So thus, a plus b is even, and addition is closed under even numbers. I'll put even integers, even though it's really the same thing. So yeah, that's what we've proven. We've proven that it's closed. So this is kind of your taste, and that box just means that we're done with the proof. This is kind of your taste of college mathematics. Now this isn't very difficult, and it gets a lot worse than this, but the concept of looking at these questions logically is new to a lot of people, and even a lot of math majors don't even know that this is what they would have to be doing. So yeah, this is a proof. We've proven that the set of even integers is closed under addition. So that is our proof. And that is actually the end of this video. So hopefully you enjoyed. Hopefully you did pretty well. Let me know how you did in the comments. And if you want to see more of this, I can definitely do another episode. Um, but yeah, I enjoyed making this, so hopefully you all enjoyed watching it. But if you have any questions or comments, let me know. But if not, then I will see you in the next video. Thanks for watching.